Alright guys, my name's Steve from Steed's Tech. Just want to talk about the diesel power source and new Turbonator. These guys hooked me up with a compound kit. It comes with the Turbonator and an S475. And this thing is really freaking awesome. So this is it right here. What's very unique about this is these two turbos are virtually the same. These are made by Garrett. Slightly different, obviously. This is a GT4205 and this is a Garrett GT3571. Now the reason why I say they're similar is because they're VNTs, variable nozzle. And what's unique about the variable nozzle, if you guys look down into here, you can see all these little fins that go around and they pivot. Now this is pretty much unique to Garrett's and Borg-Warner. So this center cartridge down here, this is a whole set. So the whole set VGTs, doesn't matter which one, you can have the 200s, the 300s, 400s, and 500s. They all increase and decrease the position this way. They call it sliding wall technology. So what's unique about this is the turbine goes into here. When you protrude up, the blades channel exhaust gas, it's Bernoulli effect, and basically the high pressure to low pressure increases velocity spools the turbo. But the problem with this is you're really not changing the exhaust housing too much from here to here. Like you are, but you're not. So in a whole set, you have exhaust brake, like EGR range. So you got your exhaust brake range, pull it down, you got your EGR, so the turbo's still spooling, but the goal isn't really to spool the turbo, but to drive the EGR and regen, generate a bunch of heat. You got your operating range, and after the operating range, you got your like blow-off range, so wastegate range. So the goal isn't to spin the turbo no more. You just want to basically prevent it from overspooling, let it slow down. So that's kind of how the turbo, the whole sets work. But when you look at the VNT design, it really doesn't matter where you put the position of the fins. If it's all the way closed, the exhaust housing sits right here. The gas can still only go one direction. Where here, the exhaust gas gets deflected, goes around the turbine and exits the exhaust housing. So you can actually stall the turbo. So if you have my Banshee VGT controllers and you do a data log, you'll actually see the turbine RPMs pretty much drops almost to zero. So that's really unique. So even if you have it super tight, which is the exhaust brake range for the VNT, that the turbo really is still going to get, the turbine's still going to get all the exhaust gas. Now, like I was saying about the diesel power source, why their turbo is unique is, so these two are the same turbo as far as the VNT. I have probably 6 or 7 other VNT turbos off Borg-Warner's, John Deere tractors, pretty much all kinds of junk. And the thing about them is you can't clock them. You're stuck. Like, I had a guy from South Korea, he sent me this. He's a really great guy. And I basically upgraded his benchtop tester, and he sent me this kind of in trade. So he sent me all the stuff back with this turbo, and I gave him a benchtop tester to upgrade his old VGT calibrator. And the goal was to put this on my 2007 Dodge. But the problem is this here. So on this truck, it sits on the driver's side. The exhaust gas comes in. So I was like, well, heck, I'll just machine it, make it fit. Well, the problem is you're not just machining this, you're machining the fin cartridge, you're machining all kinds of stuff, tons and tons of time, just to be able to clock the exhaust housing. Well, okay, so now you clock the exhaust housing. Well, now your compressor housing's in a really bad position, and it gets in the way. You can only rotate at so many degrees. Diesel power source, it kind of solved that. So it's not a, completely freely rotate back and forth like the whole sets where you just pull the little nipple off and then you can just spin it around. You're still restricted to some extent because it's bolted, it doesn't have a V-band. But you still, you still have like 12 or 13 whatever positions that you can spin it around. So if you have a 12 valve or a 24 valve or a 6.7 Cummins, if you have a 6.7 Cummins and you want to replace your whole set with their S400, okay, you just clock it around, you get it where the exhaust is dumping down towards the ground, rotate this 90 degrees so the intake's coming here, you're good to go. And it's the same thing. If you got a 12 valve or if you got a 24 valve, same thing. So like they're sending me their 24 valve manifold, and I'm just going to flip it upside down because that's the way the compound kit runs, and I'm going to run it. So it's very unique. The other really cool feature about it is if you have my Banshee kit, I tell most of the guys they want to put it on the intake horn. Well, the problem is you have all the air coming in through the turbo. It already goes through your intercooler, cools down, the air density goes up, your pressure actually drops. So now you're reading denser air pressure versus the exhaust gas, which obviously is going to be higher pressure. This thing, if you look, you have your exhaust pressure is actually tied right into your exhaust housing. It comes through this pipe, cools down, comes back to here, and here is your exhaust pressure sensor. It's all built on the turbo. Spin it around, this right here is your intake pressure. So you're actually measuring the pressure at the turbo. So you're not getting the denser air after the intercooler, you're actually running it here. So what's really cool about my Banshee controllers using this, the Banshee controllers now use dry pressure ratio to tune it. So what you do is you set the ratio. So I want a 1-to-1 ratio. So what that would mean, for every 1 pound of boost, you're going to make 1 pound of exhaust pressure. You can even go sub that. You can go all the way down to 0, but if you go to 0, obviously there's no pressure, so it's going to go wide open. But you can if you wanted to. So you can say, I want a 0.5 to 1. So for every 0.5 exhaust pressure, you're going to have 1 pound of boost. So it's totally doable. The controllers totally understands it. It just might not be really feasible. But same thing, like I said, as these two, you got the actuator sits here, it rotates this fin, and this fin then pivots like it did in here. So right now I'm using my benchtop tester, and the benchtop tester is now actuating this back and forth. So when it rotates all the way this way, the turbo's wide open. And what's really unique, they picked a great actuator, or a decent actuator for this project, because it rotates the correct direction. All these turbos do the same thing. So if you lose signal to command this, but as long as there's power, it's going to basically go to a fault position. The fault position is wide open. So if you lose signal, data link, whatever, as long as you're still power going to the actuator, it's going to go wide open, being like a limp mode, but it prevents it from being in the exhaust brake range. When it protrudes all the way out, basically 90 degrees from this section, that's your exhaust brake. So you will be able to exhaust brake with this turbo. You will be able to have a wastegate. According to Diesel Power Source, they said in a compound setup they're making 60 pounds and they're in a 40-pound drive range. So that's great. 60 pounds of intake pressure versus 40 pounds of exhaust pressure on a compound setup. That's awesome. So I'm really hoping to see that. And like I said, this is an amazing turbo. And I really can't wait to swap out my whole set VGT. I have an HE300 VG on my truck right now. Just pulling all that off, and then when I swap the compound kit, I'll have their compound kit, which is this turbo is my high pressure, S2, 475 is my low pressure, and as well as their intake and exhaust piping. So I have a true, complete Diesel Power Source kit on my truck. The goal is to dyno it with the whole set VGT prior to. Not really going to change much as far as the ratios I want to run, install the compound kit, and really see if there's a big difference in this turbo versus the whole set. But I've been a fan of VNTs ever since I started doing this. The problem is, like I said earlier, is finding ones you can clock, and I have no doubt that this turbo really is going to be a Turbonator. It is going to destroy every other turbo that's in the same range. So this is a 6271 in the compressor. I'm not sure what the exhaust turbine is, but my whole set is pretty close to the same. As long as the logic works the way I want to, it's going to be cool. But yeah, comment, let me know if you have any questions, and feel free to call Diesel Power Source. They're working on their own controller aside from my Banshee, and my Banshee is just an augmentee to their stuff. So yeah, thanks for watching.